So I hope everybody see the MC data on the screen that I have it right here. So I'm going to review whatever we go over yesterday, and then I will review what I feel like is most important, but not 100% like yesterday because we have limit time here. So the MC data is the thing is really important to understand. So I'll go over it very quick. If you still have any questions, and our team will try to answer your questions. So the first thing is MC data is a material OD. So it's a size of the stock that you're going to use, and you're going to just put in there by measuring it, and whatever the dimension that you get, you just put in the box right here. Positioning point is the point that machine is gonna use to index the tip of the tool when you call a tool from tool 1 to tool 9. And then the gap between the stock and the tip of the tool is gonna be half of the value whatever you input in the box right here. Next thing is going to be the machine length. The machine length is going to be the full stroke that the main spindle require in order to make one complete cycle. The next thing is the piece per chuck. So piece per chuck, we can have multiple piece per chuck. It's not only one, but we can have more than one, like two, three, whatever the stroke of the main spindle allow you to do. The third one is going to be a cut up tool. Like most of the time, it's going to be the tool number one because this tool number one give a lot more strength than the rest of the other tool. And the second thing is the most important thing is it give you the clearance when you come in to do pickup, and it's all about the safety. Next thing is going to be cut up speed and cut up feed. The cut up speed and cut up feed, it will related to your experience about how you're gonna cut and how you're dealing with the material. It's gonna be fast if you cut soft material, and it's gonna slow down if you cut hard material. So it's all depend on your experience. And these two feature is gonna apply in preparation only, and in the program if you're using M108, then you're gonna use this feature. The next thing is gonna be cut up end. So cut up end is how much you're gonna cut past the center. So if you have the value right here is 50,000, that means when you do the cut up operation in preparation, the tip of the tool is gonna go past the center by minus 25,000. And for some reason, if you want to run tube or hollow material, and then you want to put like positive number in there, you can put plus sign and then the value in there. So you can have positive number in there. Other than that, if you try to put positive number, the machine it will not take it. The back chuck tense length is using for somebody whoever using the extended nose collet. So if you're gonna use the extended nose collet, you have to measure the distance from the face of the sub spindle to the face of the collet. Whatever is sticking out from the face of the cap, you're gonna input in here. And this number, it will affect the cut-up operation and the end working tool. Not like that, but the next box is right here. The back work extend length is how much the material is gonna sticking out from the face of the collet after the cut-up operation. Not like the back jerk extend length, the back work extend length is only affected for the end working tool only. Next thing we're gonna have is the gang tool post. The gang tool post, you have to look at what kind of tooling, what kind of holders that you have on the machine in order to fill out this information right here. The machine comes standard with a tool on the gang and then one dock legs that can carry four tool to the front, which is the tool 11 to tool 14, and then four tool in order to work for the sub spindle, which is the tool 51 to 54. But then you have option to purchase the live tooling in order to put into the station number 9, and then you can have some live tooling to work for the front side or the face. Same thing apply for the back two posts. The machine comes standard with four static tool ID tool, so which is the tool number 31 to 34. But you have an option in order to upgrade the back spindle, the back and working both and working tools into live tools, and then you can use uh, this live tool in order to do milling interpolation. Next thing is going to be back spindle. Back spindle is come with the standard, the sub spindle using collet in order to pick up the parts or support while you're turning in superimposed mode or something like that. And the next thing we're gonna have is the basket. The basket is apply is the idea for some customer doesn't want to damage the OD when coming to pick up the parts. So that's an option you have to purchase in order to use it. And the last thing for the back spindle is also another option is the support. The support is using with the idea is for turning the long parts. Okay, next function we're gonna have is the guide pushing type. So guide pushing type, we're gonna have two type of the guide pushing. The first thing is the rotary guide pushing, which comes standard with the machine, and then it's going to support and then guide the material to give you a better grip, and then give the machine the ability to turn and get rid of a lot of problem like deflection or vibration. The second thing is the guide pushing less, which is you can choose to take up the guide pushing system so the main spindle can travel all the way out. So with this way, it's no longer the Swiss type anymore. It's become conventional CNC lathe turning function. So the next thing is the stopper. Stopper, we used to use the stopper with the tool number 20 in order to stop the material before we turn it. But since we have a lot of customer and then also we using the cut up tool in order to stop material. So I see in the software we already took out the function, the option for the stopper, so you no longer have the choice right here. That's why it's right here. It's gray out, so you cannot either pick it out anymore, but it's still there. All right, so I'm gonna give a couple minutes right here to see if anybody gonna have any questions, and then we're gonna try to answer as much as possible. All right, anybody has any questions before we move on?
So I don't see any questions in the chat forum at this time,
Okay.
Hoan.
All right, so I'm gonna move on. So before we go into the topic for today is G600 mode, which is really important to understand for programming class because we have to understand all the mode in order to control and then knows how the tool moves and then do whatever we want to do in order to uh, make it happen. All right, first thing, I want to go back to the page right here so I can show you the tool layout. As you can see right here on the gang tool, we have the tool from 1 to 5. I don't know if you guys have a problem, but my screen is kind of like flashing. I don't know why. Do we have that problem, Mr. Richard?
I see the screen scrolling real quickly right now.
Okay.
Are you on the Wi-Fi or are you on the...
No, I'm on the cable now.
So I see the screen switching back and forth rapidly.
Yeah, okay. All right, let me see. Is I don't know why. I just jumped the page and then it's happened like that. Okay, is it better now?
Yes.
Oh
No,
no,
but
this
still
page
doing
is
it.
still doing it. All right, so basically, I just want to show you the tool layout, but it's the computer is not cooperating right now. So we can use the picture right here. So you can see on the gang tool right here, which is for the main spindle, we have X1 axis, Y1 axis, and then X1 is move up and down, Y1 is move like in and out like this, and then Z1 is move back and forward in order to carry the material and push it in and out. And then we have the dog legs right here, the tool in the front, and then the tool in the back right here. So basically all the tool on the front gang right here and the tool on the dog legs in front right here is using for the main spindle. And then talking about the main spindle in the program is gonna be $1. And on the tool in the back side right here and the end working right here is gonna use for the sub spindle, which is the $2. Some of the mode we can we will be able to use the tool in the front right here in order to work for the sub spindle, but is some kind of like special mode calling. We're going to go over that also later on with the G600 mode, but before that I just want you to understand and have a visual picture in your mind. Okay, all the tool in the front right here and the dog legs right here is used to work for the main spindle, and the tool in the back side dog legs right here and the end working is used for the back spindle, which is the $2. All right, we're gonna jump to the mode right here and start working. So G600 codes is a way that citizen design in order to make the machine, to help the user to make the programs in order to turn the complex part in a very easy way. So the first thing I want to go over is the G630. I'm not going to go with the orders G600 and G630 and G so on and so forth, but I want to jump right in with the G630 right here. Alright, hope you guys can see it right here with G630. So G630, we call it a front and back parallel machining, which is you can use the front tool working for the main spindle while you using the back tool you working for the sub spindle independently. Or in another word that you can use is simultaneously. That means in $1, you can pick whatever you tool in the return, and then in the sub spindle, it will move to the end working both in order to do whatever it needs to do to finish the job. And the idea for that is to cut down the cycle time. We'll limit the waiting time to the least, so we don't have to spend much time on, the cycle time, and then you can have more production. So going to this, you can see right here is saying, okay, um, the G630 mode is also working as a queuing code also. Okay, talking about queuing code right here, we can say, all right, we have $1 and $2. And basically what I seeing this is we have two separate programs and we combine it together right now. And then in order to have the machine synchronize between movements between the main spindle and the sub spindle, we have to have some codes in order to tell the machine, hey, while you're doing this one here on the main spindle, you can do over here on the sub spindle if you're in this mode. Other than that, if you in a different mode, you cannot using this tool because it's gonna interfere with the other tool on the other side. And with that idea, so the G630 mode right here is allowed you to use the tool from main spindle, which is the tool right here you can see. It's showing you that you can use the tool number 1 to tool number 9, and then tool 11 to tool 14. Whatever tool in this range, you can use it. But other than that, in $1, you cannot use any tool if it's not allowed. For example, we have the tool from 51 to tool 54. If you're gonna command it in $1 in G630 mode, the machine is will alarm and then tells you, okay, T code is cannot command something simple like that. So apply the same method for the back spindle. It allows you to use only the tool number 31 to 34. If you're using any tool other than that, the machine will alarm also. Okay, so another thing we have to talk about right here in the G600 mode is the main spindle. It will control these axes right here on the $1. So on $1, you have the ability to access to X1, Y1, Z1, and C1 axis. So whatever you want to do with the main spindle, you can do it right here on $1. And then remember, in $1, we will control X1, Y1, Z1, and C1. Same thing, in $2, you will control X2, Z2, and C2. So whatever you command right here, the sub spindle will in action. So another argument right here that we have that is called like W0. So you can command whatever the value in here. It doesn't have to be the W0. So in G600 mode, if you command W whatever the value following the G630. So which is like this. If you have G630 W0 right here, when you have this following the G630 with the W value, the machine, it will know, okay, when we enter this mode, we want the sub spindle don't go anywhere because since we command it W0, so the sub spindle, it will not move anywhere. If you command it W.2, that means the sub spindle from wherever the position it is, it's gonna jump forward like 200,000. And whatever it happened right here is gonna consider that at the location that the sub spindle is right now is activated is right now. And if you don't command the W right here, the sub-spindle automatically will go back to the home position before it index to any tool that you gonna calling after that. And then also another things right here for the axis control right here, if you're not gonna calling any tool when you entering the G660 630 mode, whatever you command to move, for example, if you command to move G0 X something Z something, so that means it's telling the machine, okay, you need to move to this position right here on X and this position right here on Z. And this location right here is based on whatever tool is activated right now on the machine. It doesn't matter what tool that you're using for the last mode. For example, a last mode, you can use G600 mode, and then you have the tool activated, it's tool number 2. Even you cancel it already, but the tool is still stay right there. And then as soon as you enter this G600 mode right here, it will using that tool in order to move to the position whatever you command right here. All right, so we have any questions so far?
No, I'm good.
Okay. All right, so I keep moving on. So G630 mode is gonna be the mode that you're gonna see most of the time in your program. If I don't want to say, okay, you're gonna use it like 100% all the time for all the program you're gonna use later. A lot of people are gonna say, okay, there's a statement right here. So G630 is the same as G600. I would like to say, okay, it's mostly the same, but it's not exactly the same. Because if it's exactly the same, and then we will not two separate G600 mode. So to do any tool later on, from now on, to do any tool simultaneously, I highly recommend to use G630 instead of using G600. And then I will go over the G600 later on. You will see the reason why. But then right now I can say it is separate the main spindle and the sub spindle, and is allow you to use the proper tool in the right way. And then when you call a tool, it will index it to the right tool. It's not like the G600, which we go over it later, which is the free calling tool mode. And you will using this mode in order to do simultaneously from now on, because as I going out to do the training, I see a lot of customer using G600 mode in order to do simultaneously movements, which is also the machine is will work, but it will not working properly. So I will
So
move
Han,
on. Yes.
so we do have a question. Somebody asked if you could explain C1 and C2 again. And the other question is, does G630 have to be canceled at the end of this, at the end of what you are doing?
Yeah. So, okay. So the first question is about C1 and C2. So the C1 and C2, whenever you enter the mode with G630, it will allow the side that you're working on. For example, the dollar sign one is going to be the main spindle. It will have the main spindle fully access to the C1 axis, which is you can command like, okay, let me clean up this a little bit. Okay, so for example, on dollar sign one right here, if you're gonna command to call the tool with the new machine right now, you will be able to call the tool with the argument E. When you call the argument E, the machine will automatically engage with the Z-axis, whatever the value that you're gonna put it right here. If you put it right here, E0, that means you tell the machine lock the main spindle at zero degree. So the Z-axis, it will give you the fully control. What I mean about that is you can, from this moment on, you can command to move the the Z-axis to whatever the degree that you want. For example, you're gonna go G0 and then C maybe 85 degree. And then same thing is going to apply for dollar side too, but the only thing different is when you enter the G630 mode, it's separate from the dollar sign one and dollar sign two. Dollar sign one will control the C1, which is the main spindle, while dollar sign two it will control the C2, which is the sub spindle. So you can gonna command the same thing right here. You're gonna call a tool T31 at E0, and then you can gonna control the same thing C 800 and so I mean 85 degree, but then right here 85 degree right here is going to be different from 85 degree over here, because 85 degree over here is for main spindle, 85 degree right here is for sub spindle. So I hope you can see the difference, and then I hope I can explain for your questions. All right. Okay, so the next questions is the G600 mode. Is that okay. Did I, okay, so I did answer your questions. Okay, thank you. So the next questions is going to be G630 mode. So in the for the A320 machine, if you're not canceling it with the other modes like G660 or G650 or G600 mode, the machine it will stay in the same mode for the whole time. And if you, as soon as you changing the mode, it will automatically cancel the G630 mode. So you don't have to use the G600 after you using the G630. As long as you remember, okay, G600 control X1, Y1, Z1, and then dollar sign 2, which is sub-spindle control X2 and Z2, and then you can call the tool as long as it allow you right here in order to move to the position whatever you want before you change the mode, or you want to change the mode and then you can call a tool after that. It will work the same way. All right, so is there any questions here more? Okay, I can see when using the C axis to mill a radio slot, how do you implement the feed rate? Okay, I'm not quite understand it here, but I'm trying to, okay. So implement it. So when you're using the C-axis, the machine, it will understand that you're gonna engage with the live tooling, and then you will have the main spindle locking. So right away the machine it will know that in the spindle lock right now. That means you will never ever longer able to use the G99, which is the revolution, like the feed rate per revolution anymore, and it's automatically you have to change the mode into G98, which is control the machine by inch per minute. So whenever you use the C1 or C2, make sure you change the mode that you're using to do the feed rate to G98. So the machine will understand, okay, we're using inch per minute right now, no longer inch per revolution. Did I answer your question, Mike?
Yes, Hoan, thank you.
All right, you're welcome. Okay, so is there any other questions before I move on to the next mode? All right, I assume that we understanding and we don't have any other questions. So the next mode I'm gonna go over is the G660. All right, so so on the screen right here, I hope you can see it's the screen about the G660 mode. So the G660 mode, we call it a front and back simultaneously machining. But then what is different from the G630? Because the G630 is a front and back parallel machining, but also we can call it simultaneous mode machining also. So there's a little bit limit right here for the G660 mode. That's why we have a different mode right here, which is you can see the tooling that's calling right here, it reduced down for the main spindle. So the main spindle right here, you can only call the tool from 11 to tool 14 only. Compared to the G630 mode, you can call from the tool 1 to tool 9 and tool 11 to tool 14 in dollar sign 1. And dollar sign 2 right here, you see the changes right here that the T51 and T54 is allowed to call in dollar sign 2 now instead of the T31 to T34 in G630 mode. And then one more thing is right here is restricted in this like mode is whenever you call the tool on the main spindle, which is dollar sign 1, it has to be parallel in the other side, which is, all right, I'm gonna draw right here about the dog legs. So you have the dog legs right now like this on your machine, and in the front right here you will have 4 tool, which is the tool number 11 to tool number like 14 for some reason. Okay, and in the back side right here we have the tool is like setting up parallel with the main with the front, but then the tool on the back side right here is going to be 51 to 54. So the restriction in this mode is whatever the tool that you're gonna pick in the front side. For example, right now I'm gonna pick the tool 11. You have to call the same tool parallel on the other side, which is the tool number 51. If you call the tool number 11 here, and then you call the tool number 52 in the backside right here, the machine is just sitting there and waiting for you to is will sitting there and waiting for the other side to have the tool called parallel, and it will not moving on as long as you have the parallel tooling call. So, and then I believe if it's sitting down there for a certain amount of time and it will alarm out after that. So that means that limits you to, okay, you cannot call the other tool right here when you're using this tool. That means if you have two tools working, so right now if we have tool 11 call and tool 51 call, and we have like different length working on the main spindle compared to the sub spindle. For example, you're gonna thrill from the main and you're gonna thrill from the back side, and then the Z length maybe you thrilling in the main about 750, and the backside you thrilling maybe 500 only. So with the same feed rate, you're gonna use absolutely the dollar sign gonna finish first, but then it will just waiting there and then waiting for the main spindle to finish whatever it has to do, and then as soon as it see okay both of dollar sign finish already, and then it will continue it move on, and then you have to again call a tool parallel even when you just use the tool on one side in order to do it. Okay, for example, you have one, two, three. So right now in dollar sign one is tool number 11, tool number 12, tool number 13. And then you have to call on the side two, parallel the tool, whatever you have on the main side, which is 51, 52, and 53. So on the main spindle, you're using this one for spot, this one for thrill, and this one maybe for boring bar. But in the back side, the tool number 51 you're using for spot, number 52 you're using for thrill, and then that's it. You're already done for the sub spindle, which is dollar side 2, and then you're doing nothing for the tool number 3, number 53. But in this mode, G660 mode, you still have to call the T53 in order to using the T13. So one thing that I want you to pay attention right here, you might have a like alarm later say, okay, why I'm calling this tool right here on the main spindle, and then it doesn't like move the machine, it just stay right there. Okay, one thing you have to think right away, maybe in dollar side two, you didn't call the tool parallel for it. So the machine is just sitting there and waiting for the signal on the other side say, hey, I need the other tool in order to move. And one thing right here, why this mode is restricted too much for calling tool is really simple. Okay, imagine if you're gonna have the tool, excuse me, the tool calling on dollar sign one, which is the tool number 11 here. Dollar sign one, you can have the main spindle moving in y-axis like this, and then moving x-axis like this. But on dollar sign two, you have only this axis is the x-axis. You don't have the z-axis in dollar sign two. So that means if you're using the main spindle right here in order to do whatever you want in the main spindle, and then you want to call this one in the sub spindle, it will be really dangerous if the machine allow you to do that. Because right now, okay, it's gonna be wrecking the dog legs right here. Since you know that the sub spindle is gonna be aligned with the main spindle for the center right here. So whenever you call the tool in this mode, it will automatically move the front tool to center of the main spindle, and then the sub spindle right here to the center of the tool right here. So that means if you're gonna you jump to the next tool right here, that means the x-axis is going to raise up, and then this tool right here is still following in the sub spindle. It's going to break the tool right away. So that's one reason why we cannot using the tool like unparalleled in this mode. Okay, so one thing right here, it doesn't mention in this mode right here is the T argument, and then we have the argument is the A1 and A5. Let me clear this one first before I explain that. So as you have the sub spindle like this, and you have the main spindle right here, and you have the tool with the dog legs right here, and you have the tool in the front and a tool in the back. So whenever you go into this mode, the center line of the tool in the back will be matching with the center line on the sub spindle. Same thing, the main spindle, the center line of the front tool, it will be center with the main spindle. Okay, so when you call the tool, it will have the argument is A1 or A5. And basically what the A1 and the A5 does is when you call the tool, in theory, we always want all the tool and the spindle line up very good. That means the main spindle and the sub spindle center has to be 0 dead nut whenever you call the tool into G0. But in reality, it might off a little bit. Maybe in the main side, it might off like 510. In the back side, it might off like 310. So that's the reality. Okay. And then we cannot get rid of it. We have to deal with it as long as the machine performing fine, and then we're good to go. But then the A1 and A5 right here, it will let you to pick, okay, either you want the sub spindle follow the tolerance that you're gonna have on the main spindle, or you want the main spindle to follow the tolerance that you have on the sub spindle. You have a choice. But then the A1 and A5, it can only command in $1 only, which is only for the tool from 11 to 14. If you're gonna command the A1 in $2, the machine it will alarm out and tells you, okay, tool can command on this mode. So remember in mind that, okay, if you have something later on, you want to have the through hole, maybe your part gonna be like this. And then you have the through hole like this. And then the tolerance is really critical in the front side right here. And then that means you know, okay, you're gonna need to use the tolerance on the front side, which is A1. And then when you call the tool, for example, if you're gonna call the tool number 12 for drilling in the front and 50 for 2 drilling in the back, and then you want to follow the tolerance from the main, and then you're gonna put in here A1. If you want to follow the sub spindle, and you're gonna put A5 right here, but no in the sub spindle. All right.
So
I
Han?
see we have some questions. Yes.
Yeah, we have a few questions. So I answered one of them, but in G660, can you do basically boring on the back and drilling on the front in 660? So,
Okay. So that's the only questions?
yes.
Okay. The answer is no, because like I said, the main spindle, it has the axis is X and Y. While the sub spindle, you have only the axis is X only. So that means this mode is meant to build in order to do center work only, just like drilling, spotting or tapping, and then that's it. Because if you just imagine, if you move on the main spindle to bore the bar, that means you're going to move on the x-axis or the y-axis. The sub spindle, it has to follow. And then as long as it's follow, and then you out up the bucket already. Like for example, if you're gonna boring on the sub and then you drilling in the back side, that means in the back side the drilling is right now in the hole, while the boring in the front is moving, and then the machine is not gonna wait for the main spindle to be like I mean the main spindle, it will not wait for the sub spindle to be done. But then there's one way that you can do if you really want to bore in this mode and then drilling in the back. Yes, you can command to put a waiting code to wait for the sub spindle to finish, and then you can move on the main spindle. But then that's not the recommendation to do it, because if you want to do it, and then you can do it on a different mode, which is the G630 mode. And then you have the tool is mounting on the like T31 to T34 instead of like 51 and 54. So I hope I answer the questions.
So we have another question. Will then the offset for tool 11 and tool 14 then affect tool 51 and 54?
Yes, correct. So that's what I'm saying right now. Okay, so the offset is whatever you're gonna use to adjust the main spindle tool right here in order to line up with the main spindle. So when you're using the A argument right here, either A1 or A5, so you're gonna pick, okay, what side you want to have the tool center with that spindle. So all the offset and geometry, it will also affect the machine too. So is that your questions?
Yes, we had two questions, one talking about the A1 and A5. I think you've answered both.
Okay. All right. So, okay, good. We're gonna move on. Do we have any other questions here before I move on? Alrighty, so before I finish this mode, I will have another questions outline right here. So since this mode has a lot of restriction, so why we have to use this mode in order to working though? All right, the answer is sometimes you're gonna have the part or the job require more than 4 tones that you can have for the end working, which is the tool number 31 to 34. Maybe you're gonna have 5 tool, or you wanna have 6 tool, and then you can use the dog legs in the dollar side. I mean the dog legs in order to work for the sub spindle. So if the job gonna require you more than 4 tool, then just remember you have the option to put the tool in the backside of dog legs in order to have the job to be done. All right, so I'm gonna move on to the G600. Oh gosh, we run out of time right here. So I hope you guys can stay little bit longer, because the G600 mode is really important for us to understand and to make the program. And then I want to throw out as much information as possible, because at the position as a programmer, you need to understand all of this completely. Okay, so we're going to jump to the G600 mode right here. As I mentioned earlier, a lot of people are going to use G630 the same way. I mean, they're going to use G600 mode the same way they're using the G630. And the reason why I said it's not a proper way to do it, and then I'm gonna go in and explain it right now. So the same thing for the other mode. As long as you enter this G600 mode, the machine will give you ability in order to control this axis in $1 and this axis in $2. But then now you can see in $1, the machine allow you to have plenty of tools. And then you can also see here in the $2, and you can pick a lot of tools also. And if you pay attention, a lot of tool on the $2, you can call the same with $1, which is if you calling the tool and you don't pay attention, the machine it will moving crazy. Okay, for example, if you're gonna have the machine calling the tool number 31 to 34 in the main spindle, which is in your program in $1, maybe let me switch to OneNote so we can have better. Uh, how can I? Okay, stop sharing this. Sharing OneNote. Alright. Now where is it?
So we do have a question about A1 and A5, Han.
Uh-huh.
But when you're done with your presentation, I'm going to display something on my screen that'll hopefully answer A1 and A5.
Okay.
Okay, so
So
continue on.
so I hope you guys can see my screen right now for the OneNote. You see it, Mr. Richard?
Yes, I see it.
Okay. So this is how you're gonna program it. You have $2 right here, $1 over here. So as long as you enter the G600 mode, the machine, like I said, it gives you the fully control in order to call whatever tool that you want as long as you in this mode. So if I'm gonna call the tool number 31 right here, and then I call tool number 51 right here, and then I will move it to the position whatever X and Z right here. Same thing over here on this side, we're gonna move on X and Z right here. Okay, so as you know that in order to do to work with number 31, you're gonna use the sub spindle to work with the end working tool. Same thing over here on dollar side too. If you call the tool number 51, you're gonna use the sub spindle in order to work with the back side of the dog legs. So that means on both sides right here, you're gonna use the sub spindle to move in order to make whatever right here has happened. So that means the sub spindle been using on both sides. But for the program, it say for the mode, it say okay, you can call this tool, you can call this tool in this mode. And then in reality, if you command like this, the machine it will go in and then do whatever you command right here on $1. You can go back to your machine and try to command like this to see how the machine react and how the machine move. So $2, it will hang on the tool called right here while it's working on the main spindle, calling the tool T31 in order to move whatever the position that you command right here. And after you done over here on the $1, it will jump over here on $2 and move to the position for the tool number 51 to work for that. But then one thing that when I test the machine, I realized that it doesn't move to the position it's supposed to move. So that means something wrong inside the machine is doesn't understand it completely. Even it still make the movement, but if you command like this, the machine somehow is getting lost and is out of control. It's still moving, it's still waiting for the main spindle to do this, and then do this on dollar side two, but it will out of the control. The axis moving, it will not good anymore. So that's why I want to say don't use the G600 in order to work with anything that you call simultaneously moving. Okay, but then if you really want to do this one in G600 mode, yes, you can still doing it by using the weighting codes. So if I want to do this, I want to use the T31 and then T51. What I'm going to do is I'm going to put in here the weight code, whatever the number that you want, maybe 515. And then over here, you're gonna have the same thing, no, not right here, I'm sorry. I mean, it's right here. And then over here, you're gonna put the weight code right here. So the machine, when it hit the weight code right here, it will waiting on dollar side two. It will not jump into the tool changing, and it will do whatever it's supposed to do on dollar side one. And after it completed, it go to the queuing mode right here, and it will jump to dollar side two after that in order to move to the tool that you command. And in this case, when I tested, I see it moved to the correct position wherever it's supposed to. But then in order to have this one to work on, I mean, in G600 mode, you have to know where you're gonna queue in order to have the machine working properly. And again, I'm not recommend to use G600 mode in order to do simultaneously working. And then the reason why I just like give you the answer right here. Okay, stop sharing. And then I'm going back to this. Okay, so in G600 mode, it's really powerful. It gives you a lot of option in order to call a tool, and that's the reason why we have another name for this mode. It's called free parent machining mode, which is you can call whatever tool that you want, and you free to call the tools. So what is useful for the G600 mode? I can say is really useful in some cases. Like if you want to use the tool, for example, the tool number 51 to 54 only to work for the sub spindle, and then you don't want to wait for the tool in the front, because as you know, the G630 won't allow you to call the T51 or 54, and then only mode that allow you to call T51 to 54 is G660, but then G660 is restrict you to call the tool parallel. That means you have to wait for both spindle to get in the tool to sync in it before you start working. That means you're going to waste up time waiting for the tool to positioning. So this G600 mode allow you to call the T51 to 54, and then you can work it with the main spindle without waiting for the tool in the main, I mean working for the sub spindle without waiting for the tool in the main spindle to index in order to start working. So one thing right here I want you to pay attention is when you switching to the tool number 51 to 54, whatever that dollar sign that you in, that dollar sign is gonna switch the axis into the X2 and Z2 axis. It doesn't matter what side. If it is on dollar side two, great. It still keep whatever the axis is. But in dollar side one, it will be no longer X1, Y1, Z1 anymore, but it's become X2, Z2, and then right here we can also have Y1 and C1. I mean C2. So pay attention, if you're gonna use the tool number 51 to 54 right here, you're gonna need to know, okay, the axis now is changed. The sub spindle is in use in order to make the parts. There's no longer the main spindle on $1 anymore. The sub spindle is the one in control. Doesn't matter what $sign that you in. Okay, the next thing I can see is really powerful is the K2 argument right here. I see a lot of time that people running out with the live tooling pretty easy because on the A320 machine you have only 4 live tooling. So if you're gonna do okay spot drill on the live drill, maybe the hole is require okay very high tolerance. Maybe you're gonna have to rim it, and then you're gonna have to mill it, and then like something happened, you want to saw it, and then you run out of option, and then okay either you're gonna have to buy another holders in order to put it in the station number 9, or you want to put it in the end working bolts in order to give you more ability in order to do the milling or whatever you want. Right here, the K2 argument right here is offering you the ability to work from the tool number 9 to tool number to using the tool from tool number 1 to tool number 9 to work for the sub spindle. That means when you call the tool from T1 to T9, the machine automatically knows the center of the tool from T1 to T9, and then it also knows exactly where the face of the tool, the face of the part on the sub spindle, and you don't have to do anything. You can calculate really simple from basically the center of the tool to the face and do whatever you need to do, like milling a flat, milling hacks, or whatever you want to do. So I can see the K2 right here is really helpful for everyone that who gonna run into the situation we run out of live tooling on the gang tool. So again, I want to say G600 is really powerful as long as you know how to do it proper way. But I don't recommend it to use it to do simultaneously working. All right, any questions right here for the G600 mode?
It seems like no questions right now, Han.
Okay. So I'm going to move on to the last mode that we're going to need right here. And this mode is also very important because you see it for every machine, like every programming that you're going to do, which is the G650 mode using for picking up. So there's another function for this mode, but we're not going to go over too much for that function, which is the center support turning. So the most important thing is we're gonna go over is the pickup mode because you're gonna use it 100% every time. So in this mode, same thing, it gives you the ability to control this axis and this axis on the side that you are gonna working on as soon as you enter the mode. And then from this mode, you can control from T1 to T9 in side 2 and sub spindle, which is the tool number 30. But then you don't have to command the tool number 30 at all when you enter the G650 mode. It will automatically knows that you using the sub spindle, which is the tool number 30, and control it. So you don't have to command it at all. So in this mode, We also has another name for it is a superimpose mode also. So as long as you turn on this mode, the Z2 it will know exactly where the face of the part on the main spindle, and then where is the Z0 on the sub spindle. The reason why I said Z0 on the sub spindle, because we might have the standard nose collet, and it will know exactly whatever information you input in the MC data, and it knows where to go in with the Z0. So we have assemble right here in order to do the cutoff function right here. So you're gonna use right here, for example, okay, if you're gonna finish with whatever mode that you have in here, up here before, like in this case G600 mode, and then you can call the tool right here, tool number 1, and then we have the next thing right here, a G50, which is using to ship the work coordinate system according to whatever the width of the insert you're using. The reason why we're doing it, this I will explain more in deep in when we go into the making the program. But right now, just bear with me. Just understand that we're moving the work coordinate system in order to compensate for the width of the cutoff in order to have the correct number in your program. All right, so we have the weighting code right here, $1. So right here, right here. All right. So I don't know anybody can see a mistake right here. As it's saying $1. I'm gonna zoom it up a little bit. So it's a dot exclamation mark 1 and then exclamation mark 3 L 100. So I don't think the machine will understand it right here. Usually, if you want to command the queuing code, either you're gonna use exclamation mark and then the L with the value on both sides, or you're gonna do on $1 you give say exclamation mark 2 exclamation mark with the L value, and in $2 you're gonna use exclamation mark 1 and exclamation mark L, which is right here on the main spindle. It tell, okay, the main spindle looking to the $2 and looking for this L number in order to match up between these two spindle. Same thing on $2, it say, okay, tell the machine looking for the main spindle right here, which is exclamation mark 1 with this L number right here in order to match up between the two spindle. But I never using this like this, so I'm not sure it will be able to run like that without alarm or not. So somebody gonna test it later. I just catch it today, so I don't know. So for cutoff operation, we're gonna do is we're gonna have M3 turn on the spindle, and then M24 to turn on the sub spindle. So if you know about the M code already, you know that main spindle gonna like rotate that forward, and sub spindle right here with M24 is gonna rotate backward. So if somebody not familiar with the switch machine, they're gonna say right away, okay, how can you picking up with one spindle rotate forward and the other one is rotate backward? It's because kind of like outward, but then it will make sense if you look at the machine layout. Okay, the main spindle is like this way, and then the sub spindle this way. So this one, when it rotate forward, it means it rotate this way. This one is rotate like uh, clockwise. That means also this way. That means both of the spindle also rotate the same way. And if it rotate the same way, we can go in and pick it up easily, no problem. So moving on right here, we positioning the tool, and then one thing I want you to really take note right here. Whenever you have the G50 command right here, you have to cancel it before you go into the G650 mode. Otherwise, the machine it will lost, and then it will not know the phase of the part. So as soon as you come in with the G650 right here, if you have the sub spindle sticking out, say for example, this is the cap spindle, and then you have the part sticking out like this on the main spindle. So with the G650 command, the machine it will know exactly where is the phase of the part, and then where is the Z0 on the sub spindle. So with that way, whenever you command, okay, right here on the other side too, if you command it Z minus 100, so the sub spindle will know exactly that it needs to move in here and stop right in front of the part right here, and the distance right here will be exactly 100,000. So the G650 is kind of really powerful, and it gives the machine the ability to make the program is really simple. Instead of calculating the whole distance right here in order to know how much you have to move forward with the sub spindle, and then how much you want to move again in order to come in and pick up the part. It makes everything way simpler by, okay, telling the machine, okay, right here the sub spindle gonna be Z0 for the dollar sign 2, and right here of the part, the face of the part is gonna be Z0 on the main spindle. It makes everything way simpler. And also one more thing I want to say right here, with G650, whenever you turn it on, the Z2 it will superimpose with the Z1, which is whatever the Z1 is the main spindle is moving, then the sub spindle it will follow. For example, if you're gonna push the material out more this way, the sub spindle automatically knows that it has to back up this way in order to keep the distance. So it's a really powerful one that we're using for support to turning center turning. That's another function for G650, but that one I'm not gonna go too much detail right now for the G650 right now. All right.
So we have a question real quick, Han.
Uh-huh.
The question is, can you wait to use G50 W negative 0.125 until after G650?
Yes, you can do that too. But then if you don't put the G500, G50 right here, then you have to make it up with the number right here. So the machine right now, if you calling the tool number 1 right here, it will go in and read the geometry and offset everything for this one. So it doesn't matter, okay, if the cutoff the left hand or right handed, it will automatically knows, okay, for example, if it's right hand like this, it will know this side is Z0. And then if you know that you setting up the machine, you know you never gonna set the longitude on the gain tool. That means the machine automatically understand Z0 is right here. So that means in order to make the part like, for in this case 2-inch long, that means you have to sticking out the material like 2-inch, and plus with this one right here is 125 in this case. So you have a choice. If you don't want to use G6 and G50 right here, then you have to command the position for the Z coming right here, which is right now 2 inch 125. And then you don't have to do the ship right here at all. But it might confuse um, the operator or the setup guys who really don't understand much about programming at all. And then he will say, okay, why the part length is 2 inches right here on the print, but why you moving it out like 2 inch and 125, but nothing else? So in that case, it will mess up the programming. I mean the operator or setup guys a little bit, and that's the only reason why we're using the cheese 50 right here in order to ship the work coordinate system, and then we have the correct number compared to the prints that you have. So I hope I explained your questions.
So no further questions.
Okay. All right. So any further questions? Okay, so last thing I want to go over here is some argument that we can use in the G650 mode, which is the U, W, and Z. Okay, so if you go into this mode right here, G650, and so basically it will align the sub spindle, center of the sub spindle with center of the main spindle. But then for some reason you have the part with the weird shape, it's not a round shape, and then you have to pick it up upside a little bit. So you have the option right here to use the U argument, and then you can put whatever the value that upside to come in and pick it up on the art like feature. Same thing is for the W0 right here. Okay, you can command the machine on $side too if you command G650 with W. Okay, in this case, maybe you're using W0. That means tell the machine, okay, I want you to sync with the main spindle, but just sync it from wherever you at. Don't move at all on the Z axis, and then just come in and sync with the main spindle. Also, last thing is the Z location right here. You can put the G650 and then with the Z argument in there minus 100,000. Instead of just calling G650, the machine, it will know, okay, in the syncing mode, and then down one more line, you have to command G0 Z minus 100. You can put the Z command and Z argument right here in the same line with the G650, and the machine will know, okay, with this line, I will go in and sync together with the main spindle, also moving to this position right here. And then you don't have to command it down one more line. So it's either way for you to choose how you're gonna program it. But there is argument right there in order to for you in order to command and control it. All right, seems like we have some questions right here. Do we have any questions right here?
So it looks like we've been handling most of the questions. So we just had the question about the G650 and the G50, and then we still have the request to recover A1 and A5. And when you're done with what you're going to explain, then I'll share my screen and further explain A1 and A5 argument.
Sure. So for the G650, I can say if you understand it, you come in and pick it up, the Z Z2 is going to superimpose with the Z1. As long as you understand that one, and you will be fine. And if we don't have any further questions, we're going to go back and explain a little bit more about A1 and A5. If you can share your screen, Mr. Richard.
Okay, give me one moment.
Okay.
So what do you see right now, Han?
Yeah, I see your screen right here.
Front drills on the gang tool post.
Yes.
So in this section here, this is directly out of the book for the A20. So I'm hoping this is very clear about the A argument. So front drills in the gang, 11 through 17. So right here, it's very clear about what the A argument is going to do. So if A is not specified, the median value for for diameter and core data stored in front diameter tooling, machining tooling is added to X and Y1. So no specification, no A argument. A1 specified diameter core data stored in front machine tooler is added to X1 and Y1 axis. And then A5 specified diameter core data stored in the back machining data for tools 51 is added to X1 and Y1. So basically the way you look at it is no A doesn't, median value data stored in machining tool data are added to X1 for the 51s and for the 11s. A1 specified, so it's kind of doing the same thing. Data stored in the front machine for tool 11 is added to tool X1 and Y1. And then A5 is doing 51s. So hopefully this is very clear. So basically what it's doing in a nutshell, it's splitting the difference between the core, the X and Y values that may be in the machine for alignment of the dogleg. If this is basically in a nutshell is what it's doing. Is it splitting the difference between the front tools and the back tools or just the front tools? That's basically what this is saying. So A not specified median value, diameter and core data stored in front machining, which would be 11s on the dog leg, and back machining tools on the same dog leg are added to the front side. A1 specified diameter core value data stored in front machining data tool 11 is added to X1 and Y1. And then A5 specified diameter core data stored in machining tool 50 was added to X1 and Y1. So hopefully this clears up any questions we have about the A arguments. So typically no A argument is going to get you the median value for basically for the front and back, split the difference and put that value in there. Typically the values in the front and back tools are going to be extremely close. There's going to be little tiny movement. Otherwise, on-center drilling would not be possible anyway. I'm going to go back to the session now. So did that answer the question about A1 and A5 argument? If you have the book for your machine, this section is in the book and is kind of explains it more, but that was directly out of the book. I'm going to turn it back over to you, Han.
Okay, so I already go over all the mode right here. So and we kind of go over the limit time a little bit, but I hope you can understand this. And then I mean before the session that we're gonna start, like this afternoon, I will go over it briefly again, very quick, and but other than that, I hope you enjoy, and I hope you can gather some information for today. Other than that, we can like end this session for now.
So I just want to make sure that everybody's on the same page, and the next session will be 12:30 today, Pacific time, and it will be session number 4. And we just want to make sure that everybody follows the link. There's been a little bit of confusion on the links. And we just want to make sure, please join us for session 4, starting today at 12:30. You will have a new link, to follow basically to take advantage of the next session. Hopefully everybody can follow that. So I'm just going to share my screen again really quickly here. Do you see that, Han?
Yes, I see it.
Is it full screen?
No, you're still in the edit mode. Yeah, it's good now.
So thank you again. So we will have session 4 this afternoon, 12:30 p.m. Pacific time. It'll be a new link, so just be mindful. You should have received an email again with 5 total links. Each link is a new session corresponding with that session. And again, we would like to thank you for attending the class. Thank you, Mr. Hoan, for teaching. If you guys have any questions or any other comments, we will take time at the beginning of session 4 for comments. Hopefully everybody's clear on the A1 and A5 questions. There's a little bit of confusion I see with G650 and the shifting and the G50, but I know Han will clear that up once you get into your programming example and make sure that that's understood. Thank you very much.
Thank you.